Hello and welcome. This is Thomas Fischer, your IND118 module coordinator, and this is my presentation number 4 in this module. This is my contribution to our series of historical HCI case studies. As you know, we have 11 groups presenting a series of 11 HCI milestone systems in the coming weeks in chronological order. These and other systems have written HCI history spanning from the early 1960s to the recent past. With this presentation, however, I jump right into the 1980s and talk about the Commodore 64, or C64 for short. My reason for talking about the Commodore 64 is that this was the first computer I have used beginning at about age 12 until I was maybe 15 or 16 years old. It is maybe the most famous member of a group of 8-bit home computers that families have bought in the 1980s, mostly for their kids. These devices have made a profound impact on a whole generation of people, including myself, and sparked our lasting interest in computers and in technology in general. In this presentation, I want to introduce the human-computer interface of the C64 to you, but I also want to give you a more general sense of my experience of this machine and of what it was like to live and play with it. The C64 was released in 1982 when I turned 10 years old. It was produced by a US-American company named Commodore Business Machines, or CBM for short, which had been around since 1954. Until the late 1970s, the company was best known for their pocket calculators, such as the one shown here on the left. In the late 1970s, it became clear, however, that pocket calculators would drop in price rapidly and could no longer generate the profits required to operate and grow the company. So CBM decided to get into the personal computer business in 1977 with the 8-bit CBM PET product line. PET stands for Personal Electronic Transactor. Machines of the Commodore PET line integrated the computer, keyboard, and monitor in a single desktop device, and they were generally too expensive for home use and bought by schools. This machine that we see here is from the initial 2001 series. It has a very small and difficult to use chiclet keyboard and, on its left side, a cassette drive as a storage system. The monitor could only display shades of green. At this time, there were already much more powerful computers in existence, but those were usually operated by universities, large companies, and the military, each shared by many people and very expensive. Because the PET and other early Commodore computers were targeted at personal use, they had to be extremely simple and limited in order to be somewhat affordable. Yet, they were still quite expensive. This PET 2001 cost about $800 when it was released, which is the equivalent of about 3,400 of today's US dollars. The interesting history of the Commodore Company goes far beyond the scope of this presentation, but it has been the subject of a recent documentary film titled The Commodore Story, which I recommend you watch if you have the opportunity. Besides the more professionally oriented PET machines with their integrated monitors, Commodore started to produce 8-bit home computers without integrated monitors in 1980. These were the VIC-20, seen here on the left, and the Commodore Max machine, which was also marketed as the Ultimax in North America and as the VIC-10 in Germany. The VIC-20 was derived from the PET, but with color. It was quite limited, but it was also very affordable, and so it became the best-selling computer of 1982. The Max was even more limited and did not sell very well at all. When you look at these images, you may think that these are keyboards only, but this is not the case. These are keyboards that include the entire computer inside of their cases. In 1982, the Commodore 64, or C64, was released, again an 8-bit machine. 8-bit means that every memory location can hold a pattern of 8 zeros and ones, and the processor can handle one such pattern at a time. By comparison, today's computers are 64-bit based. The Commodore 64 quickly became the best-selling single computer model of all time. Commodore went on to produce and sell it until 1995. There were many competing 8-bit home computers available at the time from other companies, and the available of different 8-bit computers was different in different countries based on where companies were based, what their marketing strategies were, and also depending on cultural and legal differences. For example, there was a line of 8-bit home computers called BBC Micro, developed by the BBC in the UK to foster computer literacy. These computers were not widely available outside of the UK. Eastern European countries had restrictions on technology imports and therefore produced their own copies of some Western machines called clones. Most of the home computers of that era were self-contained devices with plastic cases, integrated keyboards, and external power supply units. Almost all of them were normally programmed in the programming language BASIC or in the much more difficult to learn but more powerful assembly language. Within 2 years of its release, the C64 also had competition from Commodore itself with the entry-level C16 and the more powerful Plus 4, which had 4 simple office applications built in. Software that ran on one 8-bit home computer model was generally not compatible with most of the other 8-bit home computer models. This had very important consequences. Back then, there was no internet. So some computer users, especially kids, had to rely on communities to exchange software and documentation. In the US, this came to be known as the sneakernet, as opposed to the internet, because you had to put on your sneakers and walk over to the neighbor's house or go to the schoolyard to swap computer magazines and software. In this way, the choice of a home computer model was in many ways a social choice. It did not only depend on how much money your family could spend on the device, it also determined which other kids you would then hang out with, share programs with, and so on. So if your best friend had an Atari and you got a Commodore, that was a serious test of your friendship because the two of you now existed in separate digital universes. Of course, most kids did not buy these expensive machines themselves. Parents did. And it was usually quite hard to convince parents to spend money on such an expensive item. Most kids wanted computers to play games, and parents knew this of course and did not like the idea to spend a lot of money on mindless gaming. What I think convinced most parents, and certainly mine, was that computers also came with a promise of a better future. Many people were losing their jobs in the early 1980s due to industrial automation, and because computers were taking over people's jobs, parents reasoned that computer skills would offer job opportunities and job security in the future. So many parents bought computers hoping that their kids would learn serious computer applications and coding. Naturally, there was some potential for conflict between kids who wanted to play and parents who wanted their kids to learn. The computer advertising industry understood this. It emphasized serious uses and the educational value of the Commodore 64, and it portrayed it as something that brings the whole family together, as shown in this TV ad for the Commodore 64 from that time.
Woke up, opened up the door to play games with my 64. But there was Mom with her mailing list, Susie catching up on the map she'd missed, and playing music a little rock. But Dad was charting his favorite stock. All in all, it's great to play and learn, especially when I finally get my turn.
Commodore, bringing computers down to earth.
The C64 was packaged and marketed in a few different flavors for different applications and markets. The Educator 64 was a C64 in a Commodore PET case with a green monitor aimed at schools. Then there was the standard C64 that most people had, the C64C with a sleeker case released in 1986, The C64G with brighter colors released in 1989, the C64GS game console without a keyboard from 1990, and the luggable SX64 with an integrated color monitor, a keyboard and a disk drive released already in 1984. The key features that made the C64 stand out within the Commodore product line and amongst other home computers in general was its relatively large memory, its powerful sound chip called SID chip, and the ability to program high-resolution graphics elements called sprites. Many kids spend much of their time dreaming about owning a computer, wondering what wonderful things computers might allow them to do. I still remember the time when I knew I desperately needed to interact with a computer without having any concept of what computers could do and what they could not do. On TV and in movies, computers were referred to as electronic brains, and for some time that was all I had to go on in imagining what it would be like to have one. I still remember one day when I was walking home from school with a classmate who lived in my neighborhood and who already owned a C64. On that day, our German teacher gave us an incomplete story, and our homework was to write an ending for that story. I found that homework very difficult, and I asked my classmate on the way home, "Hey, you have a computer. How about we type this incomplete story into your computer and we have the computer write the ending for us?" My classmate was not sure if that's possible, but he invited me into his home to try. What actually happened was that he then spent the whole afternoon playing a game named Prince of Persia on his C64 and I had to watch. That was quite disappointing. I had to do my homework myself and I still wanted to get my hands on a C64 of my own. Other things that made me want to have a computer were TV shows. There were a few of those that would introduce new models and show how to program them or how to connect them to other devices and so on. That was absolutely fascinating to me. Yet more addictive to me was a very unique aspect of 1980s computing culture called department store coding. Department stores had figured out that allowing kids to use the computers they had on display as much as they liked was a very effective way of selling those computers. Many kids spent many hours in department stores using the computers there until they managed to get their own. Eventually, what got me fully determined to get a computer of my own was the 1983 movie War Games, and I am sure many kids of my age felt the same. So many of us made our first computer programming experiences at department stores, watching over the shoulders of others, learning some basic commands very quickly. To create a basic program with multiple lines of code, each line had to start with its own number, so the computer knew in which sequence these lines had to be executed when the program was run. A very simple department store program was this: 10 print, Tom was here, 20 go to 10, and then run. This sent the computer into an infinite loop, endlessly printing on the screen, Tom was here. Other programs were interesting because they were tiny, yet they produced very intriguing effects. This one, for example. It would keep printing either a forward slash or a backward slash at random, thereby generating a sophisticated looking maze. This is how many have made their first experiences in computing and developed a feeling for the things computers can do. Eventually, my parents bought a Commodore 64 for my brother and me. Getting a computer was a big deal. Usually it was a Christmas or birthday present. It came in a box that contained not only the computer but also its external power supply unit and a handbook. The machine had a power inlet and a power switch on the right side as well as two joystick ports. On the back, it had connectors for expansion cartridges, a TV antenna outlet, an AV connector for a monitor, a serial port for a floppy disk drive, as well as connectors for a cassette drive, and a user port that could be used to connect to a printer or a modem. One reason for the typical form factor of home computers at that time was that they were designed for affordability. Computer technology was expensive, and the designers of these machines had to save cost wherever possible, including the user interface. For the vast majority of 8-bit home computers, that meant providing connectivity to the family TV set. The idea was that all families already had a TV, so they could just use that TV as a display and thereby save the cost for a monitor. This made 8-bit home computers like the C64 more affordable to more people. But using a TV would give a blurry and flickering image that was not very comfortable to look at for longer periods of time. Alternatively, the C64 could be connected to a dedicated monitor. This offered a sharper image that was much more comfortable to look at, but it was also quite expensive. The choice between either using an existing TV or a dedicated monitor was deeply cultural in many ways. First of all, it was determined by a household's disposable income. Then, it would also affect family culture. Richer kids could have their C64 in their kids' room, while other kids had to use it in the living room where the TV was. This had two effects. Richer kids could use their computers in private and freely play games, while less rich kids were in the living room under the eyes of their parents, who could make sure that there was not too much gaming going on. But even worse, less rich kids had to compete with everybody else in the family for the TV, which was not a nice situation. So if you wanted to spend a nice Saturday afternoon trying out some programming ideas, and your dad wanted to watch soccer, then you probably had to do your coding on paper first and wait until the TV was available. The C64 was connected to the TV's antenna port. To use it, one had to reach behind the TV, unplug the antenna cable, and insert the aerial cable that came from the computer. And when computer use was finished, then the aerial cable had to be unplugged from the TV and the antenna cable had to be plugged into the back of the TV. After a while, this was quite annoying. To solve this, there was a little peripheral device shown here besides the TV. It could be used to switch between antenna and computer a bit more comfortably. In my family, it was out of the question to rearrange the living room to suit the use of the computer. The computer had to somehow fit into the way the living room was already used, and so it spent most of its time on the armrest of our sofa, which was not very safe and certainly not ergonomic. It was quite common that the power connector would slip out, either because the computer was not set up in a stable way or because someone tripped over the cable, and then all the data that was in the computer's memory was lost. When you switch a Commodore 64 on, you notice a nice quality that computers have later lost for a while and then regained. There were no moving mechanical parts inside home computers of that era. No cooling fans, no spinning disk drives. So, unless it played sound or music, the C64 was perfectly silent. The image on the left is what you would see immediately after switching the C64 on. It tells the user that this is an environment to program in the programming language BASIC. As you remember, Bill Gates and Paul Allen wrote the BASIC interpreter for the Altair home computer. They kept developing the interpreter for other machines under the name Microsoft BASIC, and as you see here, the C64 had Microsoft BASIC version 2 built into its ROM. And then it says that of its 64 kilobytes of RAM, about 38 kilobytes are available. The rest was usually occupied by screen memory, the BASIC interpreter, the character set, and other things. Another interesting feature of the C64's human-computer interface was that frame around the main text area. The reason for this frame has to do with the possible connection to the TV. It was quite common that old analog TV sets scaled the TV image in horizontal, vertical, or both directions so that the outer parts of the image could get lost. In the image on the right, you see the top and bottom margins almost entirely gone. because the vertical scaling on this TV isn't quite right. This area was called domestic cutoff. As shown in the diagrams at the bottom here, this is why TV camera people in those years were trained to capture wider angles to make sure that what arrived on people's TV screens looked right again. So, as you can see, this human-computer interface was still far away from the much more accurate interfaces we have today. The styling and the color of the C64 were not as cool and as high-tech as some of the other 8-bit home computers in the market at that time. It actually looked a bit dull and boring, which gave the C64 its German nickname. German families keep their bread in the kind of wooden box you see on the right here. This box is called Brotkasten in German, meaning bread box. It has a similar odd shape and a similar color as the C64. This gave the C64 the ridiculing nickname Brotkasten, and Germans use this nickname to this day when they talk about this machine. This is what a somewhat complete and expensive setup looked like. The C64 with a monitor, a modem, 2 disk drives, a dot matrix printer, a cassette drive, and a mouse. Most Commodore 64 owners also had joysticks, which are not shown in this image. It looks like this picture was taken some years after the C64 was released because initially there was neither a mouse nor software that could use a mouse. The C64 had no internal data or program storage, and whenever you switched it off, all memory content was lost. For storage, there were 2 main options. There was the floppy disk drive, which was fast, reliable, and expensive, and basically a necessity for gaming. And then there was the cassette tape drive or dataset, which was painfully slow, very unreliable, but also very cheap. One small advantage of cassette storage was that it was possible to circumvent commercial copy protection of games by copying anything on audio cassette players. There was also a third way to load programs and data into the C64 besides the disk drive and the dataset, which was hardware cartridges. Game companies liked to sell their games on hardware cartridges because these were relatively difficult to copy. Literature on the Commodore 64 was very important, especially to learn programming. There were many books on many aspects of home computers, and there were also magazines. One German magazine I liked very much was called Input 64, which came out every month, and it had either a floppy disk or a cassette with interesting software included. Much of the software it published was contributed by readers of Input 64. This inspired me to try to write a game for this magazine. I chose this 4-in-a-row game, which I thought was within my basic programming skills, and I have actually made some good progress towards developing this game for 2 players to play against each other. But then in November 1986, Input 64 came out with an issue that included an implementation of just this game by someone else. And that implementation did not only allow 2 players to play against each other, it also allowed 1 player to play against the computer, which was way beyond what I was capable of in those days. This kind of experience, disappointing as it was, only made me want to compute and to learn more. Much software on the C64 seemed like magic to me back then because it was so far beyond anything I could do on this machine. Later I learned that a lot of that magic comes from understanding the computer well enough to avoid its weaknesses and to use its strengths. As an example, this table shows the instruction set of the C64's processor. These are the elementary operations the processor could carry out. The 2 lines highlighted here show the instructions to add 2 numbers and to subtract 2 numbers. The instructions for plus and minus. If you look carefully, you will see that there are no equivalent instructions for multiplication and division. So, when we programmed multiplications or divisions in the basic programming language, the BASIC interpreter had to take care of performing these calculations through series of additions and subtractions. Therefore, an addition took only one CPU cycle, while a multiplication using many additions required many CPU cycles and, for this reason, was much slower. Knowing this, it was possible to take these things into account and program algorithms that performed much faster than others. As a demonstration, here are two flowcharts of two algorithms for calculating the prime numbers between 0 and 100. I will not go into every detail of these two different ways of calculating prime numbers here, but I want to draw your attention to the condition highlighted in yellow in the algorithm on the left. It requires the comparison of two divisions many times within two nested loops. If you compare that to the algorithm on the right, you will find that it does not contain divisions or multiplications, but counting with different step sizes based on addition only. When we compare these two algorithms side by side, implemented in BASIC on the C64, we see that their code is similar in length. But when we run these two programs side by side in real time, we see that the one on the right runs much faster than the one on the left. The reason for this is that the one on the left uses many divisions, each of which takes up many CPU cycles, while the one on the right uses addition only, each of which uses one CPU cycle only. It was insights into the machine like this that could make the difference not only between good code and great code, but also between a good programmer and a great programmer. After the Macintosh with its graphical user interface was released in 1984 and version 1 of Microsoft Windows was released in 1985, the C64 joined the family of home computers with graphical user interfaces and mouse interaction in 1986 with the release of the GUI operating system GEOS. Like Windows, GEOS was a third-party piece of software that had to be loaded from a floppy disk and, like Windows, it was strongly inspired by the Macintosh interface. It supported software for desktop publishing and spreadsheets, but with the limited resources of the C64, these were not as powerful as their equivalents on other platforms at the time. It is quite interesting from today's perspective that GEOS was sold alongside a mouse for the C64, as you can see on the right of this screen, because there was hardly another reason to use a mouse on the Commodore 64 besides GEOS. Think how absurd it would be today if Windows 10 would be bundled with a USB mouse. This is an interesting illustration of how the relative importance of hardware versus software has shifted over the years. That brings us near the end of this presentation. One more thing that I want to mention again has to do with the social implications of home computing in the 1980s. When the price of computer technology dropped to the point that families could have computers in their homes, it was generally expected that this would open up computing to everybody, and that it would turn out to be a generally enabling development. But this was not universally so. As I already mentioned, the money a family had available made a big difference in which computer and what peripherals children could use and learn with. Another social effect of the 8-bit era has to do with gender. Computing has had a gender divide already before the 1980s, when for decades hardware was generally thought of as men's business and software programming tended to be thought of as women's business. The 8-bit home computers of the 1980s were marketed primarily to boys. Maybe because boys were more interested in gaming and more effective at convincing their parents to buy computers. In any case, when we look at the percentage of females in various disciplines over the years, we see that with increasing gender equality, the numbers of women have been growing except for the field of computer science, where the number of women has actually gone down since the 1980s. So while this technology has created great opportunities, these numbers suggest that some have been able to benefit from these opportunities more than others. This finally brings us to the lasting impact the C64 has had on the world. The most profound impact the C64 had was surely on the countless people whose interest in computers and technology was sparked by this machine. Many people who are in software development, game development, and computers today are there because many years ago they started playing with the Commodore 64. After the C64, Commodore went on to release the Amiga computers, which also turned out to be groundbreaking in many respects and sold very well. But the company went out of business in the mid-1990s. There are still people programming C64s today, mainly in a small community of game developers and in a somewhat separate community of demo programmers who stretch the limits of the sound and the graphics that can be performed on the C64. And you can find many examples of this art form online. There is also talk of a revival of the C64, and if you are very lucky, in some places you can still find the C64 performing serious work, like the one in the lower right here, still working in a car shop in Poland. There is so much more to be said about this computer, but this is where I will stop for now. I hope you have enjoyed this computer history case study of the C64. Thank you for your attention and take care.